Hey everybody, welcome to a new topic, systems of two equations and two variables. A system of two equations is a pair of equations, both of which contain the same two variables. For example, we have two equations here, and both of them consist of the variables x and y. So this is a system of two equations and two variables. A solution of a system of equations is an ordered pair of values that is a solution to both equations. So for example, consider the system of equations 2x plus 3y equals 9, 2x minus 3y equals 3. I claim that the ordered pair xy equals 3, 1 is a solution to this system of equations. And what that means is x equals 3 and y equals 1 is a solution of this equation, and x equals 3 and y equals 1 is also a solution of this equation. Let's check and make sure that that really turns out to be the case. So we have xy equals what? 3, 1. And we have the equation 2x plus 3y equals 9, and 2x plus 3y equals 3. Let's make sure that this really is a solution to both equations. So I'm going to take 3 and plug it in for x, and 1, I'll plug it in for y. So we get 6 plus 3 is 9. Okay, that checks out. But this equation has to work too. So let's see, take 3 and 1 and plug it in for x and y. And you know what? This should be a minus sign, shouldn't it? The second equation should be 2x minus 3y. So I plug in 3 for x, and I plug in 1 for y, and I get 6 minus 3 is 3. Okay, beautiful. X equal 3, y equal 1 is a solution for both equations. xy equals 3, 1 is a solution to both of these equations. So we say that it is a solution to the system of equations. Before we take to solving these systems of equations, let's just look at the kind of things that might happen. We'll take the same system of equations that we just got finished with. 2x plus 3y equals 9. 2x minus 3y equals 3. And we draw the graph of each of these lines. This line is the graph of 2x plus 3y equals 9. And this graph is the graph of 2x minus 3y equals 3. So this line has the graph 2x plus 3y equals 9. This line has this line is the graph of the equation 2x minus 3y equals 3. And notice that these two lines intersect in exactly one point. So here's the first thing that can happen. The lines intersect at exactly one point, and let's see what point this is. X equals 3, y equals 1. This was the solution to the system that we just went through and verified previously. This point of intersection is going to be the only solution for the system of equations. And that one solution is the point of intersection. This line represents the equation 2x plus 3y equals 9. This line represents the equation 2x minus 3y equals 3. The lines intersect in exactly one place. So this is the only solution to the system of equations. This point of intersection is a solution to both of these equations. Now let's look at another thing that can happen. Here's another situation that we have a pair of lines. This is y equals 2x minus 2. And notice that it's in the so-called slope-intercept form. So the slope is 2, and the y-intercept is negative 2. This is in slope-intercept form. Its slope is 2, the y-intercept is 1. And we look at these two lines, and they don't intersect anywhere. What does that mean? The lines don't intersect no solution. That's what that means. If the lines don't intersect, there's no solution. And here, that we see something that's true of lines that don't intersect. They have the same slope, but they don't contain the same points. For example, both of these lines have a slope of 2, but their y-intercepts are different. So this means the lines are parallel, but they're not the same line. They have no points in common. So same slope, different points. The lines are parallel. They don't intersect. There's no solution. There's a third possibility. Here's another example. A system of equations. And we want to see what the graphs tell us about the solution. This is pretty easy to graph. It's in slope-intercept form. The y-intercept is 1. Whoops. Okay, now I'm ready. This is in slope-intercept form. Remember, y equals mx plus b. B is the y-intercept, so I'll plot this point. Here's the y-intercept. And the slope is 2. What that means is I can go up 2 in the y direction and go over 1, and I have another point on the graph. So that's really all I need, 2 points. Okay. And what is this? Y equals 2x plus 1. Now this line's in a different form. So what I'm going to do is I'm going to find the x and y intercepts. And I guess the first thing I'll do is I'll let y equal 0. And that'll give me the x-intercept. So I have 3 times 0 minus 6x equals 3. So that means negative 6x equals 3. Divide both sides by 6. X equals negative 3/6 or negative 1/2. Okay. So y is 0 and x is negative 1/2. So that's, well, let's see, we found a solution there. This is y equals 0, x equals 1/2. Now let x equal 0, and we have 3y minus 6x equals 3. And x is 0, so I put 0 in for x, and that means 3y equals 3, or y equals 1. Ooh, I don't like the way this is looking. Same 2 points here. Ooh. These 2 points determine the line, and guess what? It's the same line. This is also the line 3y minus 6x equals 3. Both of these equations give me the same line. So I guess the question now is, where do these 2 equations intersect? And the fact of the matter is, every point on this line is a point of intersection of this line and this line. There are infinitely many solutions. Sometimes we call these things collinear. So every point on the line is a solution to both equations. Okay, solving systems of equations, the substitution method. First step, rewrite one equation so that one variable in the equation is expressed in terms of the other. Substitute this expression for the variable into the other equation. And once we find the solution, plug this into either of the original equations to solve for the missing variable. Let's try it. First step, rewrite one equation so that one variable is expressed in terms of the other. So I'm going to do this one. First thing I'm going to solve for x here. So the first thing I'm going to do is move 6y to the other side. And I'll have 3x equals add 6y minus 18. Okay, I still haven't solved for x, but I'm close. All I have to do is divide both sides by 3. Let's see, is that right? X equals 2y minus 6. Okay. I've solved for one variable in terms of the other. The second step says substitute this expression for the variable, x, into the other equation. So I'm going to take this expression for x and plug it into this equation. So I have 4x plus 5y equals 28. And what I'm supposed to do according to step 2 is substitute this expression for x into this equation. So I'm going to take the equivalent of x, which is 2y minus 6. I'm going to substitute that in for x. And let's see what I get. 8y minus 24 plus 5y equals 28. Okay, let me combine these things now. Eight y plus 5y is 13y. Now, did I do that right? Let me make sure. Eight y minus 24 plus 5y equals 28. Okay, well, let's see. 8y plus 5y is 13y. And now I'm going to take this negative 24 and move it over to the other side. So I add 24. And let's see, if I combine these, that's 52, isn't it? Now, what does that make y? Divide both sides by 13, I have y equals 13. Okay, I've solved for one of the variables, y. Now it's time for step 3. Plug the solution that we just got into either of these original equations. I'll put it in this one. So I have 3x minus 6y equals negative 18. And I just found out that y equals 13. So I plug that in here. So that gives me 3x minus, what is this? 60, 78. 3x minus 78 equals negative 18. Okay. Now I've got to move the 78 to the other side. 3x equals 78 minus 18. And that tells me that 3x equals 60. And so x equals 20. And I don't like that. Let's try it. I don't like it. (3x), x is 20, minus 6y, y is 13, equals negative 18. So that's 60 minus 78 is negative 18. That checks. But what about this other equation? 4x plus 5y, y is 13, equals 28. Nope, not going to happen. This is terrible. I checked my answers. They don't work. They have to solve both equations. They don't. It's a good thing I checked. Otherwise, I might have gone off and thought I had the right answer. Let's try this whole thing again, and let me pay more attention to my math. Okay, let's try it again. Solve one of the equations for one variable in terms of the other. And I'm going to pick the first equation. 3x minus 6y equals 18. No, negative 18. And I'm supposed to solve this equation for one variable in terms of the other. So I'm going to solve for x in terms of y, which means I want to get y on the other side of the equation. So add 6y to both sides. And I still haven't solved for x yet. I have 3x over here. I just want x. So I'm going to divide both sides by 3. So I have x equals 2y minus 6. Okay, now substitute this expression into the other equation. So I'm going to take this expression for x and plug it into this equation. I have 4, and this is x, 4x plus 5y equals 28. And I'm going to take this expression for x and plug it into the other equation. So I'm going to take the equivalent of x, which is 2y minus 6, and plug it into this equation and simplify. So I have 8y, 4 times negative 6 is minus 24, plus 5y equals 28. And 8y plus 5y is 13y. Add 24 to both sides. So I'm going to get 52. So 24 plus 28 is equal, okay. So this means 13y equals 52. Divide by 13, I have y equals 4. Okay. So I've solved for one of the variables, and this was actually step 3. Step 2, I substituted the expression from equation 1 into the other equation. I solved that equation for the variable y. Now I have to take this value and put it into the equation from step 1, that's this thing. So I plug this value into the equation from step 1. And here's the equation. Plug y equals 4 into the equation 3x minus 6y equals negative 18. So 3x minus 24 equals negative 18. Add 24 to both sides. I have 3x equals 24 minus 18. 3x equals 6. So that means x equals 2. That's our other part of the solution. Now, hopefully this is our solution. We better check. I didn't come up with the right thing last time. Good thing I checked. And I'm going to check again this time. Three x minus 6y equals negative 18. Let's see. 6 minus 24 is negative 18. Okay. So far, so good. 4x plus 5y equals 28. Let's see. 8 plus 20 is 28. Okay. Congratulations. We've done it. You know what I think? I think we better do another one of these. Okay, let's try this pair of equations and let's see what happens. Solve one equation for one variable in terms of the other. What the heck? Let's pick the first equation. So we have 5x minus 4y is negative 17. And what the heck? Let's solve for y this time, just because. So I'll keep y on the left and I'll move 5x to the other side. So I have minus 4y equals negative 5x minus 17. So does that look right? Yep, I think so. Now I actually have to solve for this variable, which means I want y on the left side, not negative 4y, but just plain old y. So I have to divide both sides by negative 4. So I have y equals, and I divide by negative 4, I have negative 5 over negative 4x minus 17 over negative 4. And that's y equals 5 over 4x plus 17 over 4. This is looking downright creepy, you know that? Okay. 2. Substitute the expression from step 1. That's this thing. So we're going to substitute this expression into the other equation, the equation that we haven't used yet. Okay. So here's 2x plus 5y equals 46. And my expression is for y. So y equals 5/4 x plus 17/4. I'm going to plug that in here. 5/4 x plus 17/4. And then step 3 says solve this equation for the variable x. Okay. 2x 5 times 5/4 is 25/4. 5 times 17, holy moly, what is that, 85? Equals 46, holy moly. Okay. I'm going to have to combine these two, so I need a common denominator. So I'll have 2x over 1 times 4 over 4 equals, no, plus 25/4 x or 25x over 4. And I got to subtract 85/4 and get it over to the other side. Equals negative 85/4 plus 46. Yipes, 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 yipes. So let's see, 2x times 4 is 8x over 4. Plus 25x over 4. And you know what? I hate fractions. I hate fractions. So I'm not going to abandon the problem, but looking at what I had here, I could have just done away with the fractions. And especially for a person like me who doesn't like fractions, that would have been the thing to do. So let's go back to this point. What I should have done, I should have looked at this and said, I hate fractions. So how am I going to get rid of the fractions? If I multiply this side by 4, I'll get rid of the denominators. And then I have to multiply this side by 4 also. Okay. 4 times 2x plus 25 over 4x plus 85 over 4 equals 4 times 46. Okay. Yeah, it's a good thing that I remembered that I hate fractions, because this is going to be a lot easier. 4 times 2x is 8x. 4 times 25 over 4, the 4's cancel, so this is just 25x. 4 times 85 over 4, the 4's cancel, this is just 85. And let's see, 4 times 40 is 160, plus 24, 184, I hope. And I'll combine these two things, I'll get 33x. I'll move this to the other side and I'll get 90. I'll subtract 85 from both sides. So let's see, 184 minus 85 is 99. And then I'll divide both sides by 33. Okay, I have x equal 3. My remaining step, substitute the value of the variable found in step 3, that's this guy, into the equation from step 1. So put it into this equation, 5x minus 4y equals 17. So here's equation 1. 5x minus 4y equals 17. And I'm going to substitute x equal 3 into this equation. Five x minus 4y equals 17. 15 minus 4y equals 17. And I don't like where I'm going right now. Oh. Yeah, no wonder I can't get the right answer. I copy everything down wrong. 5x minus 4y is negative 17. So there's a negative sign here. And a negative sign here. And a negative sign here. Okay, now I like where I'm going. Subtract 15 from both sides. I have negative 4y left on the left side equals negative 17 minus 15 so I have negative 4y equals negative 32. And then I just divide both sides by negative 4. Y equals negative 32 over negative 4. Y equals 8. X equals 3, y equals 8. That's my proposed solution. That's what I say my solution is, but you know what? I better check it. 5x minus 4y equals negative 17. Let's check. 5x, plug in 3 for x, minus 4y, minus 4 times 8. Okay, what do we get here? 15 minus 32, negative 17. Okay, that checks. Now the other equation, 2x plus 5y equals 46. So I plug in 3 for x. I plug in 8 for y. So I have 6 plus 40 equals 48. Was that 6 plus 40 is 46, which is exactly what I was supposed to get. Okay, so this is indeed the solution. And this is how we solve a system of equations by substitution. There is another method, and maybe this is, well, it might be a better method. It's definitely as good. Sometimes maybe it's easier to use than what we've just been doing. We'll take a look at it. This method is what our book calls the addition method. And the idea here is that we can multiply both sides of an equation by any non-zero number that we want. So let's say that we want to solve this system of equations. We have 5x minus 4y equals negative 17. And we have 2x plus 5y equals 46. And since we can multiply either or both of these equations by any non-zero number that we choose, why not multiply the first equation by one number and the second equation by a different number so that this turns out to be the negative of that? I'll show you what I mean. Suppose I multiply this equation by negative 2, and I multiply this equation by 5. Well, negative 2 times 5x is negative 10x. 5 times 2x is positive 10x. So if I add these two equations together, I'll have negative 10x plus positive 10x equals 0. They're going to wipe each other out. The x's will be gone. All we'll have left will be y's, and we'll solve for y. So let's do that. And I multiply both sides of the first equation by negative 2. So this will be negative 10x. Negative 2 times negative 4 is positive 8, so this will be plus 8y. Negative 2 times negative 17 is positive 34. Now I do the same thing with the second equation. 5 times 2x is 10x. 5 times 5y is 25y. And 5 times 46 is 230, I hope. And then we just add the two together. Negative 10x plus 10x is 0. 8y plus 25y is 33y. And 34 plus 230 is 264. Sure would be nice if 264 is divisible by 33. Let's see. Y equals 264 over 33. Three goes into 26 8 times. So 8 times 3 is 24. 8 times 3 is 24 plus 2 is 26. Oh my goodness, I lucked out on that. Hey, y equals 8. Well, now that we've found the value of y, how are we going to find x? Plug this into either of the original two equations. Doesn't matter which one. Now, let's try the first one. 5x minus 4y, but y is 8. 5x minus 4y equals negative 17. Simplifying, we have 5x minus 32 equals negative 17. And now I'll add 32 to both sides. So 5x, let's see, 32 plus negative 17 is 15. 5x equals 15. Then I just divide both sides by 3. So I get x equals 3. And are we going to assume that this is right? No, we need to check. Plug it into the first equation, 5x minus 4y. So 15 minus 32 is negative 17, check. Now we've got to plug this into the second equation, 2x plus 5y. So 6 plus 40 is 46, check. Okay, now I'm sure we're right. We checked our answer. Well, that worked out rather well. Let's try another one. And we'll do another one using the addition method. And remember, the idea is that we can multiply both sides of an equation by any non-zero number. So let's multiply the first equation by one number and the second equation by a different number, such that what we have here is the negative of what we have down here. So I have 3x minus 6y equals negative 18, and 2x plus 5y equals 28. And what I'm thinking is I can multiply both sides of the first equation by 2, and both sides of, I'll tell you what, negative 2. And I'll multiply both sides of the second equation by 3. So that will make this negative 6x, and this will be positive 6x. When we add them together, the x's will wipe each other out. So what do we get? Negative 2 times 3x is negative 6x. Negative 2 times negative 6y is plus 12y. And negative 2 times negative 18 is plus 36. Okay, 3 times 2x is 6x. 3 times 5y is 15y. 3 times 28, holy moly, 84 maybe? Let's see, 3 times 20 is 60, 3 times 8 is 24. Okay, I'm convinced. I am convinced. Now we add these together, and the x's wipe each other out. Negative 6x plus 6x, 0. The x's are gone. 12 plus 15 is 27y. And 36 plus 84, holy moly. Oh, but let's see. 6 plus 84 is 90, plus 30 is 120. Okay. Oh, I was making it a little bit too hard on myself. Let me just check myself here. I don't like what I'm seeing. Wow, no wonder I don't like what I'm seeing. 3 times 5. No, that's right. 3 times 5 is 15. Let's see, negative 2 times negative 6 is plus 12. Something is definitely not right here. My math is not right. Let me stop and check it. Okay, I'm back. My math is correct. I wanted this to be the same problem that we did by the substitution method. And so for this to be the same problem that we did by the substitution method, this should be 24. So let's see what happens. Multiply this equation by 3. I have 3 times 2x is 6x. 3 times 5y is 15y. 3 times 24 is 72. And then I add these together, and let's see. 30 plus 70 is 100. 6 plus 2, 108. Okay. Yeah, I wanted this to be the same exact problem that we did before. And now we solve this for y. We divide both sides by 27. And that's going to give us 4. So we have the solution for y. How do we get x? We plug this into either of the original equations. So let's try this. 3x plus 6y. No, 3x minus 6y equals negative 18. And y equals 4. So that means we have 3x minus 6 times 4 equals negative 18. And that means 3x plus 24 equals negative 18. No. Negative 6 times 4, negative 24. There we go. And so I add 24 to both sides. So 3x equals 24 minus 18. And that means 3x equals 6. Divide by 3x equals 2. So our solution supposedly xy equals 2 and y was 4. Now, do we believe this? We probably shouldn't. So what we need to do is just check. And again, xy equals 2, 4. Let's make sure it's right. Plug it into both equations. 3x minus 6y. So that's 6 minus 24 is negative 18. Check. 2x plus 5y. 4 plus 20, 24. Okay. We plugged everything back in. Our proposed solution works for both equations. We're good to go. Now, before we stop, there's one more thing that we should do. We can't necessarily assume that things are going to go exactly the way we want them to. So let's look at what can go wrong. Okay, here's something that can go wrong. Let's do the addition method. I want these x's to kill one another. And so I'm looking at this and I say, if I multiply the second equation by plus 5, I'll have 5x here, negative 5x here. The x's will wipe each other out. So that's what I'm going to do. I'm going to multiply the second equation by 5. The first equation is okay. So I get 5x minus 35y equals 10. And 5 times negative x is negative 5x. 5 times 7y is 35y. And 5 times negative 2 is negative 10. And we add these together and the x's wipe each other out. And the 35y's wipe each other out. We get 0 on this side of the equation. And we get 0 on the other side of the equation. We tried the addition method and we get 0 equals 0. Well, this is symptomatic of something. When we get this, it means, we were working with the same line. What would have happened if I had multiplied by negative 5 here? I'd get 5x minus 35y equals 10. Oh, exactly what I have up here. So when we do the addition method or the substitution method and we get 0 equals 0, this is symptomatic of the fact that both equations defined the same line. So really, we have infinitely many solutions. If we want a solution, just pick a value of x and a value of y and plug it in. No. Pick a value of x, plug it in, and solve for y. It'll work for both equations. So if we want just one of these infinitely many solutions, let's take x equal 2 and plug it in to the first equation. Okay, so I have 10. Wow, look at this. 10 minus 35y equals 10. I'll subtract 10 from both sides. That'll give me 35y equals 0, which means y equals 0. So when x is 2, y is 0. That's a solution. Do we want, and it's a solution for both of these lines because these lines are one and the same. So when we get this, 0 equals 0, it means there are infinitely many solutions. Both of these equations define the same line. And if we want to get just one of these infinitely many solutions, take an x value, plug it into this equation, and solve for y. And that solution will work for both of these equations since they both represent the same line. Now, is that the only thing that can go wrong? No, there's something else that can go wrong. Okay, this looks similar to what we were doing. It's not exactly the same. Again, let's solve by the addition method. And I take a look at these and I say, you know what? If I multiply this second equation by 5, I'll have negative 5x here, positive 5x here. The x's will wipe each other out. So that's what I'm going to do. I'm going to leave the first equation alone. And I'm going to multiply the second equation by 5. So I have negative 5x, good. 5 times 7 is 35y. And 5 times negative 6 is negative 30. And I add the two together. 5x plus negative 5x is 0. 35y. Negative 35y plus 35y is 0. 10 plus negative 30 is negative 20. Now this is even more perplexing than what happened in the first scenario. How can 0 be equal to negative 20? It can't. This is impossible. And what this is symptomatic of is the fact that these two lines never intersect. And think about it. What does it mean when the two lines intersect? Where they intersect, that's the point that's a solution for both equations. Well, these two lines never intersect, so how can they have a solution? They can't.